Okay, so Happy New Year and welcome to Defin episode number 444. And today we're going to talk to Mr. Gardner from New York. I'm sorry, but you said some other place. I forgot.
Brooklyn, New York.
Oh, okay. So it is still New York. Okay.
Yeah.
So welcome to the episode, Tim.
Thank you.
Tim's, sorry. Is it Tim's?
It's Tim's. Yeah,
Tim's.
it's Tim's.
Okay. So I thought it was Tim or...
I go when I'm like introducing myself to waiters or something. I say so people are having a short interaction. I say Tim because we can just skip over the like Tim or Tim's debate.
Or you're going to say there are more of us.
Yeah. Right, exactly. Or it could be less than one. It could be 0.3 Tims.
True. Yes.
So maybe it's nice to introduce ourselves. So this is me, Vijay from Holland.
Yeah, it's Ray from Belgium. And Tim's.
Tim's from New York again. So.
Yes. Yeah. So can you give us some introduction, about yourself?
Sure. I guess the most sort of interesting project I'm working on now is a system called Arcadia, which is the integration of the Clojure programming language with Unity 3D. I'm working on this with my very good friend and collaborator, Ramsey Nasser. And we've been developing this thing for about 5 years. And it's been going through various phases of development, a sort of slow burn that whole time. And we recently had a full beta release of it. And we are also currently engaged in a company called Arcadia Technologies, where we're going to be developing lines of products that are directly based on Arcadia and take it from there.
So before we get deeper into Arcadia, can you give us some, layman explanation of what Arcadia is and what it is doing?
Sure. Arcadia is perhaps a place to begin to answer that question is what is Unity, which is the system that we're integrating Arcadia with. So Unity is a game engine and development platform, and a very widely used one. In other words, it's a system that people use to develop and publish video games. And one of the salient features of it is that it can target multiple different platforms. So PlayStation, iPhone, Android, Xbox, like many different desktop, many different systems. And it is, I think, over half of all mobile games are made in it. So it's a quite like industry standard system to use. It's not used as much for like massive AAA games like Destiny or something like that. Most of the time, companies making games like that have an in-house engine that they've built up themselves over the years. But for smaller developers or sort of smaller games, Unity is probably the first stop that they go to. And one of the very interesting aspects of Unity is that it, unusually for a game engine, actually has a managed runtime.
Mm-hmm.
So a lot of times these systems are built in C++. Because of the rather demanding performance characteristics of games and the tradition of everybody writing video games in as low level of language as possible. Right. So there's both a technical reality, which is that you want them to be very, very fast on an underpowered device, which is sort of the trick here, and having a particular kind of fastness. Right. So the kind of fastness you need for real-time animated interactive games, which is different from the kind of speed you'd want in like high frequency trading or something like that.
Yeah.
And so there's that sort of technical reality. And then there's also just a tradition where a lot of the wisdom and know-how in games is sort of inherits from people trying to get them to run radically like underpowered systems like an Atari and a a lot of the wisdom has been sort of, lore about how to write a game has been in that vein traditionally. It was only sort of recently, arguably, that making a game in a higher level system was feasible because the hardware had caught up to it.
Yeah.
So Unity, again, unusually for a games engine, has a VM inside of it, and specifically it has a cut of the CLR, the Common Language Runtime, the same system that C# runs in, right?
So Unity has .NET or .NET CLR inside it, or?
Yes. So
The other way
Unity
around.
is there's an understructure of C++, but then there's a scripting layer on top of that, which is the CLR. And the way Unity programming generally progresses is the user defines a particular kind of class in C#. And then Unity notices the existence of this class and incorporates it into the world you're building out. And you compose your game out of this.
So the class could be, I don't know, a mage or whatever, or a character or something like that.
Yeah, more or less. And they're using an entity component system of sorts. And there's different interpretations of what an entity component system is. They have a particular one that it's built on. They may be transitioning to a slightly different idea of that, or sort of extension of that idea, but it is basically an entity component system. Without getting too deep into that, the idea is that you have a sort of, the world is composed of a set of unique IDs, and the behavior and data of these IDs are expressed by hooking so-called components up to these IDs, right? The IDs are called game objects, and then everything else is components. The components are instances of classes that the programmer writes in C#, in addition to classes that they just ship with Unity and that they can attach. And these things give them their substance and behavior in the universe. Then during the run of the game, in response to different events and to just like a new frame in the animation loop, it fires off methods that are defined on these component classes, right? As a sort of callback system. And that's your game. So that's what Unity is. Does that make sense so far?
Yeah, it's great. Yeah.
Okay, so that's what Unity is. And so out of the box with Unity, you get a physics engine, which can do like really pretty fast 3D physics simulations or 2D physics simulations. You get a lot of support for in the incorporation of art assets. You get some other niceties like player navigation support, light baking, some graphical things. Unity has its own idea of how to write shaders. Shaders being programs that run on the GPU, the graphics processing unit, rather than the CPU, which the programs that non-graphics programmers write. And then it can take all of these different ways of writing your program and export it to all of these different targets relatively seamlessly, which is a quite distinctive aspect of Unity. So, and that's a very compelling like combination of features for many programmers and game studios. Now, again, what was it?
So, before when Unity started, so this C# layer or whatever, is it something of a newer thing, or is it since the beginning?
As far as I know, it's there from the beginning.
Okay.
And one of the distinctive things about Unity, again, is that it had a scripting layer on top of that. So you weren't just dropping directly into C++. Typical Unity development almost never deals with C++ at all. Yeah, so the whole thing is usually just through C#.
But is the scripting thing similar to, because there used to be, I'm not sure, because I tried some 3D stuff almost 15 years ago, I think, and 3ds Max 4 or 3, I don't remember. So there used to be a 3D script in that one, and also Maya had Maya script. Is it something similar? A
bit. One of the big differences, or like Emacs Lisp or something.
Yeah.
So it's scripting in the sense that you use it to extend the system you're interacting with the exception that this is also how you're going to be doing all of your programming for your game, right?
Okay.
So it's much more sort of mandatory to have some kind of like you have to touch code if you want to do something programmatic, right? And the code you're going to be touching is going to be in the scripting layer. The other distinction I draw is that just the language you're scripting in is not a sort of super high level language like that. It's C#.
Yeah.
So, it's in this sort of realm of between, depending on who you ask, is it compiled, is it interpreted? It's a little of both, similar to Java, right? Where there's this bytecode representation, but it's relatively low, it's relatively like high level. There's a garbage collector. It's just a bit of both. And there's like types and things like that.
So it's like full C# environment. It's not like half-assed C#.
No, it's the full thing. It is C#. So C# bytecode. They're running an instance of the C# VM, the CLR, and they're emitting CIL bytecode, which is like the bytecode representation of it. So it's the same thing. Specifically, the system they're using is a fork of another system called Mono, which can run on many different platforms. And that's a fork of, there's all sorts of licensing, vagaries that we don't really need to go into. But so it's the real thing. It's truly C#.
Okay.
I guess the Microsoft have their own 2D and 3D engines. I guess this is a different thing from the Microsoft stuff?
Yeah, this is a different thing. This is to the best of my knowledge, I can say more than that. It is a different thing. It's Unity is it's its own company. I think some of the other infrastructure was recently acquired by Microsoft, but not of Unity, just sort of affiliated programs. Like I think Xamarin has been acquired by Microsoft. Yeah. So, but Unity is its own entity.
So it's not related to, or it doesn't use Direct3D or something, or DirectX, or.
I'd have to dig through it to figure out like exactly.
I think we should go a bit higher than going even. It makes more sense that we talk about so CLR is the interesting part in Unity now. So that is the way you use Clojure on top of it, right?
Yes, exactly. So by virtue of the fact that it is really and truly the CLR, and they are really and truly emitting bytecode, if you can come up with any way of producing that bytecode, then you'll run. And Unity couldn't stop you from doing that if they wanted to, right? Or maybe they could if they really like forked the VM and were like scanning all of your bytecode to make sure it looks the right way. But they'd have to do something crazy like that. And
they're not Apple.
You're right. So we'll get to there in a minute.
Okay.
And that means that if there is a version of Clojure which can compile to CIL bytecode, then it'll run in Unity. So 5 years ago, and I can go into sort of personal history about how I came to this juncture, but
of course we would like to. So how did you end up getting into this kind of venture?
Yeah. So I guess I'll just sort of put a pin in how Arcadia got started, and then I'll circle around to that again. So I was an art major in college, so studio art, illustration, and sort of cartoons and drawing and a little bit of painting. And my senior year in college, I started to program a little bit through a system called processing, if you're familiar with it. It's sort of a little sketch.
Oh yeah, processing, yeah.
Yeah, it's what Quill.
Quill is used, yeah.
Yeah, Quill, yeah.
And that was pretty cool. It was for throwing together little graphics things. I went to graduate school at NYU for a program that was about sort of creative experimentation with programmatic stuff. I got a little bit more into it there. I was fascinated with this idea that you could in principle, visualize the structure of mathematics. And and the idea there is that if you can come up with a visualization of foundational logic for mathematics that scales in the right way and is sufficiently expressive to provide like recursion and definition and things like that, then you might be able, by extension, to visualize anything that has a well-defined foundational treatment. So, which is a lot.
Yeah.
I didn't really, know what I was doing at the time, but I was obsessed with this idea that you could come up with this categorically more powerful form of visualization for all sorts of things. And I mean, if I was doing that now, I would say that it would be something like a visualization for a theorem proving system like Coke, and see where you can go with that. But as I continued to pursue it, it became increasingly clear that, to really do it would be like a PhD or two. Right. And I didn't feel like, as an art major, I would probably get into programs that would support that. And I was just like, okay, I've got to move on from that. But I was still really interested in this idea of visualizing how we're dealing with a computer. Most of my experience at that point was through Java. And I was getting into C++ some, because that's what a lot of the so-called creative coding tools are written in. Things that you're going to make sort of graphic, like art things in, and interactive applications in. But the way I was still thinking about logic a lot, and people saw that I was trying to sort of replicate. I was trying to come up. I was obsessed with like notation and coming up with ways of notating logic in that. Some people were looking over my shoulder and saying there's this new thing called closure that people are talking about. Like Lisp in general seemed to be the direction I was drifting in because of the way my sort of notational systems were going, and Clojure in particular. Then, complete coincidence, I found myself on a gig sharing a workspace with David Nolan. And I was talking about logic, and at the time he was working on core logic, and I kind of looked over his shoulder, and he was like, "Dude, you gotta check this out more." And so then I taught myself Emacs, I taught myself Clojure, I got all the way into it. I joined that workspace, and for like 5 years, I was just there. David Nolan was like a couple of desks over, and I was, breathing all of that air, and that was a really terribly like transformative and experience for me. And Kovas Boguta was also part of that space. If you know him, he's a Mathematica guy. He did like Session and a bunch of other kind of mad science stuff with Clojure. And then one day at an art show in Chelsea that I'd heard about, somebody was showing a programming language that was written in Arabic, right? So it was a Lisp, more specifically, that where the text you see is actually rendered as Arabic, and which changes the way it works a bit, because it flows in the opposite direction from the usual way. And this is about how programming languages are typically assume English as a kind of, and so no matter where you live and what language you speak, you are kind of forced to buy into English assumptions, assumptions of the English language. And I was one of the few people who could actually write a program in it, because a lot of it follows just from the structure of Lisp. That guy was Ramsey Nasser. He wound up joining the space. And then one day over a handle of bourbon, we were, Ramsey was a games programmer and had a lot of experience with games development. And one night we were just hanging out in the studio and talking about Clojure and Unity, which he had a lot of experience with. And we realized that there actually is a branch of Clojure out there that can compile to CIL bytecode. And if we sort of hack it a little bit, maybe. And therefore, like in principle, we should be able to get it to run in Unity. if we sort of go into the code base and we edit out a few lines and we make a few little tweaks. And I think that night we got the basic proof of concept for this, that we could get that, Clojure compiling inside of Unity. The branch of Clojure in question is Clojure CLR, which is a very old cut that was sort of there almost from the beginning. It was one of the PMs that Rich was considering from the start, and it's even in the name of Clojure. Supposedly the CLR in the word Clojure refers to the CLR. So it's been maintained since then by a wonderful gentleman, David Miller, sort of as a hobby, and it's sort of quietly been keeping up to pace with the main line of Clojure all along over all these years because of this one guy's work. And then once we realized we had this thing, it was like, oh my God, we can really do a different kind of game development with that. And then we were off to the races. So we continued to work on it sort of as a passionate hobby. Eventually we had this sort of announcement of the first version of it we were willing to say is worth, the sort of alpha that we were willing to say is worth playing around with. That got a bunch of attention. We did a bunch of talks. And then in the time since then, as our own kind of passionate hobby, we've been building it out more and more, trying to converge on a more or less stable release of the system, where the API at least is stable. And last month, we made that beta release. So now the Arcadia API is stable, and we're encouraging people to be building systems on top of it and trying it out. We've also secured some funding to start our own company on the basis of this. And what is it?
I said excellent. That's really good. Yeah.
Yeah, it's great. I mean, it makes a lot of this much more possible now. So now that Arcadia is in place, we're going to be, again, building out game products and game development products on top of it, and just seeing how far we can run with that.
Yeah.
Nice. It's a very interesting direction. So you started from art and then got into programming and then turned into functional programming and then finally ended up in, I don't know, Clojure CLR.
Yeah. Well, CLR and doing aesthetic stuff. So it's kind of, there is a something constant there, but
yeah.
it's a little bit windy.
But it's an amazing story as well if it all comes off, because essentially, like you say, kind of like crazy dream, is now turning into something that might take you a lot further. Yeah. So
yeah, exactly. And hopefully it can take game development a lot further.
Yeah. Because I did some processing and quill things some time ago. Not. I don't know. I need to think a bit because there was some New York artist. He had some project or something, and then I was took over some Clojure code from. It's in 2014, around something at that time. I don't exactly remember when it was. I need to look it up. But yeah, it was really nice to see, like having a processing window, and then you keep typing Clojure, and then it just changes the stuff. There is a really live environment that was amazing.
Yeah. I think live programming in a artistic context is fantastic.
Yeah.
And part of it is that live programming can mean many things, right? There's, in fact, it's a semi-old idea. I mean, it's a really old idea if you really want to get into history. But in terms of how often people use it, there's sort of spatterings of it all over the place. But there's a big difference between live programming in like a JavaScript console, even as JavaScript, or a system where it kind of serializes everything and then restarts quickly whenever it senses a change in the code, and live programming in a language that was written from the ground up to support it, like Clojure, and written well from the ground up to support it, like Clojure. I think that's something that games programmers are not used to. So the ideas people have of what live programming means could be quite different in Arcadia. One of the things we're trying to do is communicate to people what real live programming can be like, where any part of the system at any time can be redefined in the same environment instantaneously, and you see those updates. And in addition, these updates are supported by a very extensive data story, where you're not just doing like control flow redefinition, but very important parts of your program can gracefully be represented as persistent data, meaning the cost of like failures or mistakes is less because you're not just mutating everything all over the place, and the connections between the different parts of your program are relatively sparse. And that gives you this freedom to play around and really sculpt the logic of your system.
So what, I mean, maybe I don't know if you even do any web programming these days, but if you were comparing it to something like Figwheel, for example, where you can have an application running and then you change something and, you don't have to go back to the very beginning and log in again and do everything, is it a similar feel, or is it a similar concept for the game programming that Figwheel has? Is that something we can relate to?
Yeah, I mean, there's even a flag in Arcadia that enables sort of pseudo Figwheel style programming where it listens for changes to files and it'll just reload those files if it sees a change. It's not doing the full like walk of all the macros to try to figure out like the complete set of things it needs to reevaluate to be sure that it's updated everything it needs to. But we could do that if we want to. The other thing we can do is just throw new logic at the world that is put together. And it's relatively easy to just sort of copy and paste that in. I mean, the way we have it set up now, I think it's fairly easy to, just with that, have the live programming experience. One of the differences with, so far with between our system and web development has to do with just the structure of games and the some of the ways that games are perhaps distinct from the web. One of them is that oftentimes games just are kind of imperative simulations of what's going on. For certain very important classes of games, this is not the case, like a simple card game or something. You could consider that whole thing in a very pure sort of functional way. And, on an Android device, that's good enough, right? There's just not that much going on to hit any kind of performance hurdle. But for some kinds of games, you really do want very fast, 60 frames a second, lots of stuff going on, physics simulations, a lot of math happening. And that is traditionally not a great fit for functional programming at all, let alone dynamic functional programming, right? I've been listening to some other episodes of this podcast, and one of the points people, sometimes make is that there's perf trade-offs in terms of, A, you're functional, B, you're dynamic. And, one of the things in Clojure is people can obsess about perf and like multi-methods versus protocols and all of this stuff. But it doesn't really matter. I mean, we're already here, right? We're already in this world. And for us, that's not acceptable, actually. So I think one of the reasons some people, and this has come up now and then on like Hacker News when people have remembered about us, is like, oh, how could you do Lisp in games? The whole thing seems like a complete non-starter, let alone Clojure, which is this sort of weird Lisp.
High level of that.
Super high level Lisp. And that's kind of true. And here I'm going to get into the nitty gritty if that's...
Do it, come on. Unbox those numbers,
Exactly. Until you apply an unusual level of.
So we're gonna read out the code now. Open parentheses.
Right. So why are dynamic languages slow?
Is that a question for us? No. I know it's a rhetorical question. It's okay.
Rhetorical question.
We'll let the audience stew on that one. It's like...
Well, just like what are some reasons why a dynamic language is slow?
All right. We're doing a question answer. Okay. So of course, when they have the garbage collection thing, they have to check all the objects, all that kind of stuff all the time.
You have to do that in a static language too.
Oh yeah, that's true. Yeah.
But why do you have? Why is it? What about a dynamic language puts more pressure on the garbage collector?
Well, it's constantly recreating objects and creating new stuff all the time as you recode things and as it evaluates things. It's intermediately expressed, isn't it? Because there's a top level expression of, do this, and then the implementation varies according to the conditions. Even in the JITs and stuff like that.
Yeah, well, there's the. The JIT would make it faster usually, right?
Yeah.
If you have a full-on like JVM style JIT where it's just sort of doing induction on the code base and analyzing it for patterns and optimizing the image.
So I'm getting it wrong now, so let Vijay have a go.
let me be wrong now.
Exactly. Come on.
I want. We have voice. No, I think it's probably because in dynamic languages you don't have any runtime information available or pre-compiled stuff, and also maybe the lifetime of an object is pretty tricky to identify, and also reflection obviously. So you need to constantly do the reflection to identify what type of an object this is.
So what about in an imperative dynamic language?
Like
Python or
it's kind of
or Ruby or.
But in that case there is an interpreter, right? Because you're not actually compiling, so you're essentially submitting your program to the interpreter. Yeah.
Or maybe another question here, and I'm fishing, which is a bad. Well, I would say that really there's not a lot that is inherently slower about a dynamic language than a static language when you really get down to it. There is an overhead to doing type checks. Yeah. Right, so you can't just jump to the method definition on whatever system you're in. So there is that. That's not the big one. The big one is boxing, right? Mm-hmm. And that's where all of these objects are coming from, right? So you need a pretty good allocator and garbage collector to be able to keep up with that. And even then, you need to be. These allocators and garbage collectors do exist. Like the JVM has a great one. V8 has a great one. Modern cuts of the CLR have a great one. But it gets down into there's all these trade-offs and it's very complicated. At the end of the day, though, you're making lots of objects.
Yeah.
And sometimes you can get away with that. Sometimes it's going to all be cleaned up after you. But the other way of doing it, but they're on the heap, and you're going to have to deal with that sooner or later. The CLR, unlike the JVM, is designed to allow another way of dealing with numerics, right? So in the CLR, the JVM does something similar to this too. But in particular, if you pass by, it has better support for user-defined value types. There's any support really for user-defined value types, meaning types that similar to like primitives on the JVM are going to be effectively passed by value between, and that means that you can avoid boxing them. Now, and for people who are like listening,
in JVM, it's pretty well. It's like a few years ago, right? Until then, we didn't have box primitives, so JVM caught up with this thing. I think I don't exactly remember. Probably Java 6, Java 7. Period, maybe. I need to look at it.
I'm not really familiar with the history.
But
the basic idea is that, just to get everybody up to speed, I guess, is because this is stuff that people usually don't need to worry about at all. The language is supposed to take care of it. Most of the time when you're passing by, and some people might like get mad at me for saying passing by like reference rather than passing by reference and so on and so forth. But
we're among friends, don't worry. Okay.
Yeah, are you passing pointers objects around, or are you copying byte values around?
The values, yeah.
So the idea is, if it's a pointer, you are copying just the minimum number of bytes you need to know what region of memory you're supposed to be pointing at. And that's effectively passing an object, right? This reference. But usually that involves some idea of the heap. Right, because that object lives off in the heap somewhere. And that's where the garbage collector and the allocator needs to worry about, because keeping all of that sorted out and efficient is a task for a almost impossibly like sophisticated system, which is why there aren't very many of them, right? They've been done like less than 10 times to the full industrial level. And then the other way of doing it is that you have a sort of bit representation of something like a number, right? Like a float or an integer or a long or a short, or then you have all these different ways of doing it. And those are going to get copied directly into the memory that the method or function is looking at.
Yeah.
And if you're doing that, you can just bypass the heap altogether, right? So that's, you actually are copying something, but it's faster than, in a certain sense, it puts less pressure, memory pressure on the system than passing by reference would. And it's all in the stack. You don't need to collect it. When you're done with it, it's all good. So in the CLR, you are allowed to, now in Java, I'm not an expert on the the way the JVM deals with this, but basically you can do something like that with a couple of types, like the numeric type, the numeric primitives, which is a closed set. There's like 7 of them, and there will be forever. And or I mean, unless they start adding more. But point is, that's not the user's decision. You don't get to add more value types that are going to be passed by value rather than reference. On the CLR, you actually can define your own. So if you want a vector type that, like a 3D vector that you're going to just pass by value all over the place, you can do that. And people do, right? So there's lots of these zero allocation, right? Because you're just copying them between regions of memory. You're not putting them on the heap. Types flowing all over the place in the CLR. Now, the only way you can actually do this, where you know how to copy one thing from one place to another, is if you know the type at compile time.
Yeah.
Right? Because otherwise you know how.
Yeah, you don't know how to allocate. Yeah. How much time how much space it's going to take.
Right. Exactly. Yeah. So, and this is a problem in a dynamic language for us, right? So the alternative, if you don't know what the types are, is to basically wrap them in an object, which is boxing. Yeah. And then you pass that object around, and at the bytecode level, you know how to sort of take it out and look at it and treat it as an actual value type instance, and then put it back in and all of this. But that means that for every value type you're dealing with, you are allocating a new object.
Yep.
So if 1 + 1 = 2, so that's like the objects you're dealing with, right? If you're dealing with it on the pure sort of function level, and you don't have any other information. Now, so that's kind of a non-starter for us. And if you have this constant allocation on a VM that doesn't assume you're going to be writing this kind of program, like the VM we happen to be using, and you're putting it on a little device, this might be problematic. Yeah. Maybe for some games, actually, you can get away with it, but not the general class of games. However, the CLR has a deeper concept of generics than the JVM. Whereas in the JVM, generics are sort of generic types are really type erasure. So it's all going to get sort of erased at runtime, and they're not making new types to fit. On the CLR, you can actually, it will make new types just for the sort of generic signatures you're making. Okay. And that means that it's going to allocate, if you say, okay, this is a list of, or this is a, this is a function, and there's going to be a type parameter in it, and I'm going to give it an integer or something. It's going to make the correct amount of space and memory to fit that value type. Right. In Clojure JVM, there's a file somewhere where they have like hundreds and hundreds of interfaces defined to support primitive passing non-boxing numbers back and forth between primitive type-hinted functions up to like 4 for like long and ints. Is that it? Or maybe just longs. Are you familiar with this?
No, not really, because I don't use that level of optimization.
So there is a little bit of support for non-boxing type information on the JVM version of Clojure, but it's, again, a closed set. And if you want to do something else, you're out of luck. We can't do that. It doesn't work for us because the user could define any kind of value type they want.
Yeah.
But we can, in principle, use generics to achieve the same effect. So if we come up with a way of making closure functions responsive to generic types,
Yeah.
that means that we can actually, with one definition, emit a special kind of closure function that knows how to take any kind of value type and correctly size itself to that, and therefore avoid boxing.
Mm.
And what this means is that we can have a much broader form of non-boxing closure than on the JVM.
Mhm.
I'm not going to make any claims about our perf characteristics versus the JVMs, but I will say that it means that we are feasible for extensive numerics on the CLR, right? To the point where, in principle, we're as fast as C#.
Okay. So technically, this is because of the feature that CLR is providing you, right? The ability to define the value types.
Yeah.
Yeah.
Exactly. So it's the value types plus the generic
Yeah.
type system.
Mhm.
This does mean that we have to have a more powerful kind of type hint,
Yeah.
right? So we have to be able to communicate that sort of thing, and we're still working out some of the details of what that'll eventually look like.
Mm.
But that's one of the most exciting things about the Clojure CLR compiler we're working on. In Ramsey's, I should say, this has been Ramsey's project. So I've been spending most of my time working on the high-level code for Arcadia and the Arcadia API, and Ramsey's been focusing on getting some of these compiler things landed. And I mean, we go back and forth, but this is the general thing. Ramsey did an amazing job getting this thing together over the past couple of years. And the other thing is just doing an overhaul of the current implementation of Clojure CLR to get all of these optimizations in place. So the way that maintaining this port from Clojure JVM to Clojure CLR at all was feasible is by as much as possible doing a copy and paste. So David Miller has been basically copying and pasting the two things. And but if you really, it's a different VM. It's a very different system in a bunch of ways. And if you want to have real performance, you kind of need to write the whole thing again, or at least the emission phase where you're actually spitting out the bytecode. And so we are doing that. We are writing another variant of the Clojure CLR compiler effectively in Clojure because we already have one version of it that works. So what we're working towards is basically a metacircular closure, or like a bootstrap closure.
Yeah, closure on closure. Yeah, but this has been a big thing or a point of discussion comes up every now and then. I don't know why Clojure is not hosted on Clojure or something.
Yeah. So I mean, I think Nolan's. Well, I mean, there's different things that can mean. The one that we're working towards is not really host agnostic because it's very much about the exact bytecode that we're
yeah.
One of the side effects of this, in addition to being pretty fast and on the CLR, is that we're going to wind up with a very powerful bytecode metaprogramming library for Clojure on the CLR. Meaning that if you want to inline custom bytecode for a particular Clojure form and express that as a macro, you'll be able to do that.
Oh, so it's almost like writing assembly in C.
Yeah. And inspect it. So it's like I think it's a common Lisp feature where you can just say, oh, what does my bytecode look like? Oh, there it is. Again, without really, it's not so much that we're like, oh, you should be able to do this, as that we can't stop anybody from doing this given this technology we've built. And what this means is that if you want to make a new effectively special form, we can't stop you. I think this is interesting for Clojure because one of the sort of limits that people hit, or questions that people hit up against, is this perf thing, right? I mean, there's a question of this is a high-level language, so we shouldn't be worried about that too much. But if you're defining a really wacky kind of mad science system, one of the limits you hit in Clojure is perf. You're not going to hit a limit with sheer expressivity. If you had an infinitely fast computer, you don't need to worry about any of this. And so the people do wind up a bit worried about that. And a lot of the libraries I see, a lot of the thought and the sort of art of it is a balance between perf and these really sexy sort of Clojure idioms. but we can actually, with this library, drop down beneath the usual floor for that into the absolute bytecode level. You can do that on a JVM too. You can emit bytecode if you want there and load that up and stuff. But I don't think people have built out that feature as much as we have to build it out for ourselves. So anyway, well, right. So what we're winding up with here is a system that is very high level by virtue of being closure at all, but can also drop down to the lowest possible level on the CLR. This very steep gradient there.
But can you do something similar in the C# environment already? Like you write C# and then you write the bytecode or IL, whatever they call it, on CLR, and then combine them?
You absolutely can. I mean, the emission library is still there. The problem is that the C# is not built for metaprogramming.
Yeah, exactly. So this seems like significant amount of work to get this going to the level where you want. So what is the guiding principle? I mean, why all this pain? Just to get closure?
Well, for 5 years, it was basically a passionate hobby, right?
Yeah.
And a friendship thing. I mean, it's an excuse to hang out with Ramsey. I said to all my students, if you want to get into programming, find somebody to embark on an insane project with, right? At the end of that, you will be good at programming. But 5 years pass and it's there, right? So we actually have all of these things, or we're very close to having a lot of them, and we're realizing that this could be enable a categorically different form of games programming, right? And that could have, that's something worth sticking out.
Yeah. What you're saying here, just as a sort of a small aside, really, is that it turns out that if you're running your programs on the CLR, you might get a lot better performance out of it, even for sort of standard programming models, not just the games programming models.
I mean, with our, I want to be very careful here because it's any kind of performance claim that I haven't benchmarked. I'm very,
Yeah. But you're holding out that kind of dream or that possibility. Yeah.
Well, I'll say that if you want to go there, and there's a lot of reasons you shouldn't, but if you want to go there, you are not limited by anything in the language in terms of the kind of performance you can get with the system that we're probably going to wind up with. If you can emit your own bytecode, then there's nothing about closure per se that's going to be slowing you down at all, right? Whether it's idiomatic closure, whether it composes well with other pieces of closure, whether it can, correctly deal with a deep walking macro or something like that, probably not. But if you know what you're doing, if you're and if you really want it, have it, right? Which I think is one of the great appeals of closure. It is a language that enables this radical freedom about the kind of program you write. Yeah. And that's one of the reasons we think it's a really great fit for games programming, as a creative tool. It's that I don't want to be worrying about the language when I'm writing a game. I want to be just flowing with the creative process of making that thing.
So does it mean my Skyrim will have REPL finally?
Skyrim is not written in Unity.
Well, one day, you never know.
Well, yeah, I mean, that's one of the, I think the way I think about this, there's one level of what we're doing is about making games development much more productive, right? So maybe something like Rails for game development, something where you have a much sort of faster, more expressive system to quickly iterate and make games and maybe express them as data, merge them together, a framework for saying that. That's just very far removed from the overwhelmingly imperative and sort of type-laden and kind of hacky game systems people more usually write them in. And a studio using such a system could have a massive competitive advantage over another one, like a casual game studio or something. So that's from one business perspective, something that we're very interested in. Another level is what does it even mean to have a game? In practice, I think a lot of games are sort of rather constrained imperative simulations that you kind of puddle around in. And one of the reasons why games are considered a great fit for object-oriented programming, I think, is that the kind of game you're making is sort of the circular thing. It's like games are a great fit for object-oriented programming because object-oriented programming is the only option for making a game. So the in a Skyrim or a third-person shooter or something like that, that's actually not a bad fit for object-oriented programming in some ways. You have these physical objects that are literally bumping into each other in a world, like billiard balls. But what about narrative or right? It's not a great fit for that kind of structure. Most of the research into narrative systems for games, as far as I can tell, is sort of based on logic programming and things like that, which are just like a very different kind of, or solvers, like a very different approach to these ideas. And it's also not a great fit for a data-centric programming model or something that cuts across concerns, right? Where you want to be able to merge game aspects into each other, stuff like that. And another aspect of games is that once you've defined the system, there it is, and you're kind of hindered by the limitations of an algorithm, right? I mean, you have a computer; it's a machine that's running some code, and however interesting your experience is always going to be bounded by that. I think one sort of extreme example of this is maybe No Man's Sky, where everybody was very excited because there's this promise of a kind of transcendent experience of an infinite universe. Are you familiar with the No Man's Sky?
No.
It was a game that was like widely advertised, an indie game that was like going to be impossibly ambitious, where they would be generating deterministically an almost infinite universe, right? That would fill up the sort of memory space of your computer in terms of the possibilities. But it was deterministic, so you can fly back to every planet, and the planet would be kind of generated on the spot by a pseudo-random algorithm. So you could always revisit it again, right?
Okay.
And fauna, the whole thing, and it would be a completely continuous universe. You can fly from one planet to another in this sort of unbroken chain. And they did that. They sort of screwed up the release of it in a couple of ways, and people got very disappointed about that. But then now it's actually a decent game because they kept releasing patches. Anyway, one of the problems with this approach is that you do start to feel the limitations of any algorithm, anything that we currently know how to make, short of hard AI. There's just going to be a constrained system inherently, right? Like we don't know how to encode a certain kind of richness into a computer.
Yeah.
What you can do is get a human to show up in the system. So if you have live programming in almost a performative context, where somebody as like a narrator or just another player, but a player who happens to have a REPL, right, in the system, what does that look like when you're in a shared world with this level of control and expression? We've done some performances actually where ourselves in New York, where there's like a projector in the back of the room that is with a 3D world of some sort on it. And there's a website that the audience goes to, and as soon as on their phones, and as soon as they go there, their phone just displays a controller. And you can and as soon as you log on to the website or visit it, a little character drops into the world, and that's you. But everybody in the audience is in the same world, right? It's just one screen. And then we say, okay, you're one team, you're the other. And then in response to what the audience is doing, we start trickling in more and more game mechanics and modifying the world as a live programming thing.
Right. Okay. It's like overtone for games.
Like what?
Like overtone for games, like a live music concert. You're doing like a live game programming concert. Wow. Yeah.
Well, I mean, what was interesting is that it really worked. It's like people got really engaged in it because they know that it's a unique experience and reacting to what they're doing, the very real parameters of the system. So I'm very interested in what that might look like if you take full Turing completeness as like part of the medium that your game is in.
It would be super cool to have a REPL in the game, right? Then you'll be like Thanos with Reality Stone. You just keep reloading the whole thing in the way, whatever the way you want, and then keep changing everything.
Yeah, exactly. And I mean, some of the more kind of appealing versions of this, which we've already done proofs of concept for and everything, is you go into like virtual reality or something, and you're in the world, a REPL pops up in front of you, and you can just reprogram anything you want as persistent data. So you can like snapshot a part of it, transform it as closure data, put it back out there. Oh, I didn't like it. Go back. We've already like stored a couple of versions of it in a vector somewhere. I mean, it's this great fit between that functional persistent model and creative work, really.
Yeah, because I think at the moment people have like these scripting languages on top of their game environments, but that definitely feels like a much shallower kind of version of what you're offering.
Yes, and explaining the difference to people who aren't already familiar with Clojure is one of the one of our things we need to do. But yeah, I really think it's a quite different thing. Clojure is this very subtle system in a way. Like it's many different things that all sort of come together and make a whole that's difficult to quickly explain, right? Like it's very, and this is one of the struggles for people in the Clojure community, is how do you come up with like the one line or the elevator pitch for Clojure per se?
It's red pill, blue pill.
Right.
Alice in Wonderland. You'll enjoy it. Don't worry.
Yeah, right. But like,
sounds like a drug dealer. It's okay, just take it. You're gonna have fun with it.
The first hit is free.
I think it's a serious problem. I mean, when I was teaching, one of the things we would do is once the students were fairly caught up with the basics of programming, we'd just assign them over a weekend. Here, you learn Go, you learn Phoenix, you learn this, that. We just throw them a language that we hadn't taught them at all before. The point being, you can do this. You're a programmer now. You know JavaScript. You know Ruby. You can code, and that means that you can teach yourself a completely new language that we haven't taught you yet, and you can do it in a weekend. We did it.
Yeah.
One of the hardest languages that I only assigned this once was Clojure. And I think it's part of that is the tooling around it. It's really hard. It's just hard for newcomers.
So you don't let them use Emacs then?
Oh God, no. Well, that's part of the. I live in Emacs. I do all of my work.
Perfect.
Oh
that's
God,
all
no,
what we wanted
that's
to hear.
Part of the. I live in Emacs. I do all of my work.
Yeah.
I can't, like, how do you recommend Emacs to? It's like, oh, use a language, just learn Emacs, right? Like, you have to be in the place I was 5 years ago, where it's like, I will learn this language. I will bend heaven and earth to learn it. And I mean, now fortunately, one of our great assets in Arcadia, and something that's really kept us going through this time. And you're asking, why would you go through this pain? Yeah. We have an amazing community of people who've been using it from the beginning. Just spontaneously like using it. And that's really kept us working on this thing for a long time. And right now, they are just doing a lot of work in terms of tooling integration. That we don't have the resources for ourselves right now, but people are just spontaneously picking this system up and really getting the Emacs integration, and there's also Atom integration. Basically, as soon as we can get good NREPL integration, which we already have a basic version of it, but if you have the whole thing, then that opens up a lot of other editors too. So the tooling problem sort of goes away there. But yeah, I mean, back to what I was saying, that the other issue for us is saying, given that it's going to be a somewhat steep learning curve, why would somebody give Clojure a shake at all? Right? Do we have a live programming story that's different from what you could do in Lua or hot reloaded C# even, or something like that, or F# if somebody gets around to a good F# port to Clojure. And without knocking those languages, I just think that what you don't have is a metaprogrammable, dynamic data-centric, which is the real Klingscher system, like language for talking about that stuff, really. And if you did, it wouldn't have the same kind of like momentum as Clojure does.
Yeah.
It's a quite distinctive language in that regard.
Yeah, I think, well, being a Lisp, it's like that, isn't it? Because, it's the reason why other languages are not Lisps, because if once they get all of those things, they just become a Lisp.
Yeah, right. Well, exactly. Or they might be like Mathematica, and they sort of shift, make it not look like a Lisp. But yeah, and it's also fast enough. That's the other thing, right? Like Clojure is always compiled, so you can, in principle, make it really fast. Clojure is a quite fast language, really. When you compare it to, another language I love is Mathematica. And Mathematica has the best excuse for being slow of like any language I know, which is that it's doing the lambda calculus effect. It's actually a rewrite system, and that's how it does all evaluation, is through like transforming data structures. But what you lose there is this ability to have a static bytecode representation that you're constantly, emitting every time a new form shows up.
But it's interesting, like you say, that, and this is a bit of it's on and off topic really, is that many programming languages, just the big sort of famous ones, like Python and Ruby, are not fast, but they're still popular. So it's definitely, speed is a thing in certain situations, but it's not the only thing. A lot of it is tooling and community and being able to tell a story, like you say, having some, killer features or some killer apps or some use case that can just really show the difference of this thing.
Right, exactly. And I think for us, it's going to be my suspicion is, that it's going to be videos. So what we can do is show something like a picture's worth 1,000 words. So a video is worth like 1,000 words times how many frames you have. We can show what you can actually do when you're in a REPL in a world, a Clojure REPL. There's just no way of doing that in another language, really. Where the whole thing is just data. You tweak the data structure. Now it's real. Something happens in the world that you didn't anticipate. You say that's cool, and now you have the data structure. Back and forth between them, this clean, flowing, non-anxious, way of dealing with it, where you're just thinking about the system you're making, the game you're making, the experience you're making, and you're in it. I think that's the best argument we can really show.
So using Arcadia essentially would mean that I would build my entire game or whatever the thing that I'm building in completely in Clojure then. So I could use all the libraries or at least the Clojure core libraries and everything.
It's a slight difference. You still have to port it all to the CLR. In practice, a lot of the, especially the sort of interesting libraries, have a certain amount of interop.
Yeah.
You're going to have to come up with some way of porting it. That said, you can, for all the ones that I've looked at, you can do it.
So you have core async transducers and all that stuff, or does that?
It's a matter of we have transducers. Transducers down. Core async is, it remains to be done. One of the things to watch out for is that, again, sometimes the performance. You have to know that it's the right context to use a tool like that. But in principle, all of these tools are usable. Whether that's going to be something that you use at like edit time before the game is actually running on a phone, but you're just you're trying to set up the system that is going to, set up the system. That's, all of that stuff is fair game, or something that runs relatively infrequently or something like that. For the inner loop where it's just going really tight, we actually think it's fine to just do imperative programming there. Why not? Clojure is perfectly good imperative language if you want to use it that way. Write a couple of macros to sort of sugar it up a little bit, and you've got you're doing it. And that's one of the things that we're exploring too, is what is the interaction between these two layers, the very functional, pure data layer and the inner loop, which is just the world kind of flowing between frames of the program and mutating itself. This sort of how do you gracefully negotiate between functional and imperative programming like that?
Yeah. So spending all this time in building all this game engine stuff, do you get any time to actually play any games?
Yes. I mean, I'm trying to, like, I have to, no, I'm very susceptible to games. I don't know. I like, I have a lot of Steam games that I play. I like kind of weird, arty horror games. And there's also a game called City Skylines, which is like a SimCity variant, kind of a very good one, but there's something about it that's incredibly addictive.
I think that the some sort of a horror game or something. I think the one that I really liked was some time ago. I'm not a really big game player or anything. Most of the time I spend my life in Skyrim. So, but there was a Limbo or something that was super cool game. Like,
oh yeah. I started playing like Skyrim 3D. I mean,
with the VR, yeah. How is it?
The VR version of it. Yeah, I mean, these are all cool games. I think with again with RPGs like Skyrim, I wonder what would happen if you could incorporate more of the academic research that's being done into narrative into games like that. Again, these sort of solver-based systems, like there's a lot of work people are doing and kind of thoughts that they're doing, but I think a lot of it is maybe not directly implemented in these things. And I wonder if language where you can just spin out a new programming paradigm, such as Clojure, would be a better fit for that kind of thing.
Yeah.
Yeah, I was wondering, one of the things I'm interested in is like how because you've got an art background, so how do the art assets get integrated? Kind of, because I think my son actually is also doing like games design and he's looking at the artistic side, and his friends do some programming, he does the artwork and all the kind of, it's this like integration of the assets and the programming are a little bit, they're a little bit rigid, let's say, it tends to be that he does some of the artwork and then they integrate it and then it's kind of like done and he's out of the loop at that point, which seems a bit, that doesn't seem like very nice, Is that something you could change or?
Well, I think, so there's a couple of questions. One is, has to do with like the structure of assets at all.
Yeah.
So if you have a 3D model, that's a rather complicated mesh.
Sure.
Usually define it in a 3D modeling program, like Blender or Maya or something. And then you bring it into Unity, and now it's available for programmatic access. And for Unity to slot into the right place so that it can export it cleanly. And by virtue of it being a mesh at all, and this is in the case of like a 3D thing, there's this, that's a bit difficult to, that can be a little bit difficult as data because it's an arbitrary graph of like points and stuff. So you could still probably come up with some cool ways of like doing, graph algorithms on it and 3D algorithms on it if you wanted to write that. But then there's other things like what's the mesh going to do, and usually define that in terms of a skeleton. So like a sort of a much smaller number of points inside of it, which determine how the mesh should deform when like somebody raises their arm or they turn their head around and stuff. And that's easier to access programmatically. Or you could have a number of meshes that are each tagged with some information so that then you can mix and match them programmatically or something like this. And actually there's one of the like oldest like members of our community is this amazing artist, Joseph Parker, who every year makes some kind of thing in Arcadia. There was one where many members of the community, in addition to Parker, but I think Parker was leading it, made a game called Swapland, I think, where it's a little top-down shooter, but all of the monsters that you're confronted with are generated on the basis of other assets. And so those are just programmatically cobbled together. The generations.
Right, okay.
It's really just a bunch of Clojure maps that all kind of, so it's all functionally defined, and then it builds these monsters for you. I think that, so I think that in that sense, you can, at the asset level, actually have a kind of have a way of structuring assets that lends itself to programmatically nice data. Usually you don't, but you could. And I think you could have very powerful results by going down that path. We've already seen some instances of that. Another way, and there's another thing you mentioned, which is that just these tended to be two different people, like the programmer and the artist, and like living in different worlds to some extent, which is problematic if, and there's many reasons for that, but one of the problems you get is in trying to put a kind of holistic product together, right?
Sure.
What we hope is that if you're in a situation where you can actually have the designer or a artist sit down next to the programmer and have the programming process be fast enough that the artist can be like, oh, actually, I kind of want it to be like that, right? You can do it as fast as they say that. So a much, much faster feedback loop and iteration cycle between these, what are usually two very different sides of the production process. I think that could be really, really powerful.
Yeah.
I think I was trying to remember if I heard your name before or something, because the processing thing that I was talking about, I did something with almost 7 years ago. There was something like an year-light calendar thingy.
Yeah, I worked on that for a moment, actually.
Yeah. So I think I was the guy who inherited your code.
Oh, yeah.
So I was the guy who picked it up, and then I had to make it more web application sort of thingy. So that was my experience with processing. It was funky though to make that kind of things with Clojure at that time.
Yeah.
Good times.
That was like in the very early days of Clojure scripts too.
Yeah, I think so. Yeah, pretty much. Clojure script, and then Quill was pretty new as well. So it was almost 6-7 years ago or something like that. Yeah. That was a pretty interesting project, and especially with I had to port all the astronomical algorithm stuff by copying from C++ and trying to figure that shit out. So that was super fun. Anyway,
I think I think like creative stuff in Clojure again is a really good fit.
Yeah.
I think that it's not Clojure is usually used for like server-y stuff and like data stuff and these sort of big, enterprise-y applications. But it also works in a much smaller form, I think, like a phone.
So you're based pretty much on the Clojure CLR thing, but aren't you a bit concerned about Clojure CLR being like a following project rather than, because most of the efforts Rich and the gang are putting are basically on JVM.
Yeah. Right. So this is one of the weird things about where we stand. So one point is that David Miller is continuing to Clojure CLR is up to date. Clojure JVM doesn't actually move that fast. It's it's not really a fast changing target. Sometimes it feels like it's kind of done, right? Like there's not
in a good way.
Yeah, it just doesn't change that much. Yeah. And one of the reasons for that is that design work is really hard, right? If you have to get it perfect. Right? First, you have to get the first time perfect, and that's really tricky. I also think that and we're going to have to make some decisions too, especially with like the type things that might deviate a little bit from the JVM. Our philosophy is just like, so be it, right? We get the core library, we get the core system in place. Changes to our expectation is that changes to the Clojure JVM are going to sort of trickle in over time, and we'll update to them when we get around to it, or when somebody in the community wants to help us out. This is all open source. But in the meantime, we have a working system, right? That you can make games in. We see Clojure as a means to an end. And we are already compatible with a certain version of Clojure, right? And that's like, there's no promise of full backwards compatibility with every Clojure library, in the same way that there isn't between Clojure script and Clojure.
Yeah.
Very, very different system.
So what is the plan for Arcadia then? Because there is this open source component that is essentially the programming environment. Can I say that Arcadia is a game programming environment with Unity, with Clojure? Is that,
More or less, yeah. I mean, I just call it a system because it's like it's a framework.
Of course. So that is going to be open source, right? That is the open source product. Yeah.
It's all out there.
Yeah. So what are the next plans? I mean, where is the project going to, and what are you working on? If you can reveal some details.
Right. So I can't get into too many specifics about what the next thing is going to be right yet. But for us as a company, as Arcadia Technologies, we're working. But I will say that we are working on like game development products. And game development products that are not, you don't have to be a Clojure user to use them, right? So the idea is to make game development products that are equally applicable to C# developers. We think that's really important because nobody's using Clojure. In games, there's a bootstrapping issue here. For Arcadia itself, so it's out there now, it's in beta. And as we go, we're going to be updating it. We don't foresee huge changes to it moving forward. We want a lot of that kind of thing to be expressed as libraries. One of the things that we're going to get is a integrated package management system. So because we want to really encourage user libraries here and code reuse, and that'll allow us to keep Arcadia relatively small and hopefully relatively low maintenance.
And so right now, is it at a stage that I can build my game in Clojure and then actually get it to publishing? Like, can I publish a game already?
Yeah, with a couple of caveats. So right now, we don't support export to iOS. Because you can't emit types, right? So you can't actually evaluate code what Clojure does on an iPhone, unfortunately.
But is it still true though? Because we have REPLs and Python as well on.
But that's using
iPhone
JavaScript core. I think that's the difference.
No, but because we have this ISH or something that's still in beta. It's like a shell on the iPhone, and that has Python now. I'm not sure what they're using, but
so they might be interpreted. Rich, right? So they might not be actually emitting executable code. Or execute like at the bottom, like machine code, right?
I think it all uses JavaScript core at the bottom, all the dynamic stuff.
Right. So that's the one caveat. It's a pretty big caveat, I know. As we as we continue to do work on Magic, we're going to get to a place where you can actually export it to iOS.
Because that's like one of the biggest platforms at least for casual gaming
stuff. It doesn't really make sense to make a game that can't export to iOS as a casual studio, like if you're targeting mobile, right, in a lot of ways. But I might be saying, well, the products that we're envisioning, that's not going to be an issue for the way we're doing it. So we'll be able to get these products out of the door, even before we've solved that.
Okay. Awesome. Okay, I think we are.
I'm downloading it. I'm really excited about it. Actually, I think it's a fantastic system, and your explanation actually has got me going because I've always kind of been a bit. I've seen the demos, and I've always wondered whether where is it at? Is it ever, because I know it kind of like where you were very active a few years ago, and then it kind of like I guess for whatever reason it just the noise went down. But it's really great to see you back again because we've
been working in the background.
Yeah, sure. I don't mean to offend, No.
I mean, totally. And I mean, I think, well, again, there are these recent things with like Clojure and the contribution process and everything. I think one of the issues in the background is just that when you're defining a foundational system, the pressure to get it perfect is paralyzing almost from a creative perspective. Right, like and Clojure is such a. You feel like you're dealing with like one genius's masterpiece, like very individual. There's this guy Rich Hickey who kind of like descended from heaven and curled up in a hammock, and he like metamorphosed. And this beautiful butterfly came out, but you don't really understand it. And it's got all these like subtleties and details and opinions and stuff. And I think people can find that really. humbling and difficult to touch sometimes.
Sure,
But it's also just a fun system to play around in and to do mad science tricks in. For us, the need to get it right was we felt that maybe a little bit too intensely. But we think we're there now. We're pretty happy with the system we wound up with. And the direction it's going in now. The other thing is that we didn't have like funding or anything before. So
So it's slow burn,
Yeah, exactly. But now if you're trying it out, I will just say one last thing, which is that be sure to get on the Gitter. So because the community of people using this is amazing, and people are incredibly friendly and very, very happy to answer any kind of questions and give people help.
Fantastic. Yeah, that sounds great. I mean, I'm definitely up for it. And like I say, my son is, and his friends are like, they're a little gang of, they're trying to make a few games and stuff. So, when things are right, when you've got a few more demos of the new system up, I'll start to encourage them,
Yeah, definitely. I mean,
okay, fine. Yeah. Yeah, cool. All right. No holds barred. So do it.
All right.
So that's a fantastic first episode of this new year. Thanks a lot, Tim, for your time.
Yeah.
It was I think we learned like a bazillion things about game programming now.
That's fantastic. I mean, this has been such a great episode. Thank you very much, Tims.
Yeah. Thanks a lot.
Thanks for having me. Thanks so much.
Thank you. So
before we go, I do want to quickly thank a few Patreons. Actually, we have to pay our tributes,
respect,
pay our respect. Yeah, tip our hat to people who give us a few tips. Yeah. So if you don't mind, I'll just quickly dive in there and thank. There's like four people. We're trying to do it 4 at a time so that it doesn't get overwhelming. The first one is Will Acton. Thank you very much, Will. Awesome stuff. The next one is Nathan Peel. And Nathan has been Peel Junk, so it's his email. But and then the third one is Kevin Harold Rearskog. I don't know if I'm probably horribly butcherizing that one, but Kevin works. I know Kevin, so thanks, Kevin. And the final one is a friend of the show, previous guest actually, Mr. Arno Boss, who's doing the Heart of Closure this year in Belgium. So shout out to Arno. Thank you very much.
Yeah, check out the heartofclosure.eu, I think, website. Yeah,
and the Lambda Island, of course,
Yeah, Lambda Island, and it is happening in August at some point.
Yeah.
August 2nd and 3rd. Check out the website. I think it seems like a wonderfully put together, very nice new conference. On the same note, Dutch Closure Day is almost sold out. We have, I think, 7 spots left at this time.
Wow.
The CFP is still open. So if you want to talk about closure or you want to share your experience, go to closuredays.org. And
do we have enough time to get someone in to make an Arcadia video game for Closure Days?
Yeah, that'll be super cool.
Yeah, come on, Tim. Do it remotely, okay?
Yeah.
That'd be amazing. Yes. So, live coding, how to make Skyrim in Closure. That's going to be super awesome, exciting talk. So that's it from all of us for this episode, and we'll see you again in a couple of weeks, I think. And this has been a fantastic talk again. Thanks a lot, Tims.
Yep, definitely.
Okay, bye-bye.